Hey everybody, let's talk about stoichiometry. All right, this is usually a difficult subject in chemistry. A lot of people freak out, they don't want to do it. Well, we're going to look at the basics of it. All right, this is going to be like a three-part lesson. The first up, we're going to go over what is stoichiometry and the two easier problems. All right, it's going to be difficult only if you don't practice. Okay, so first of all, we already talked about a mole. Remember, a mole is a unit of a substance, kind of like a dozen, like 12 eggs equal 1 dozen. All right, well, 6.02 times 10 to the 23rd atoms equal 1 mole. And moles help us go from grams to moles using something called the molar mass. All right, molar mass, grams per mole. All right, to find the molar mass for, like, say, H2O, we have H, there's two of them, times its atomic mass, which equals 2.02. We have 1O times its atomic mass, which is 16.0, gives us 16.0. Add these up, we get 18.02 grams per mole, and this is my molar mass. So this is like the link between grams and moles. All right, now we're going to be looking at chemical equations, and they must be completely balanced for you to do any kind of stoichiometry problem. If it's not balanced, stop there and balance it. All right, so just as a reminder, okay, we're going to be using something fancy, or at least I say it's fancy. It's called the mole ratio. All right, this mole ratio is like a little bridge between one compound to another. So say I started off with 25 grams of calcium chloride, and I want to know exactly how many grams calcium nitrate would be made. Okay, well, this is what we're going to do. We're going to do a stoichiometry problem, and it's going to contain this mole ratio. That's right. You see, because these are the coefficients that are in our recipe, aka the chemical equation. All right, so we're going to be looking at these coefficients, and it is always the unknown coefficient above the given, and we're going to look at what this looks like in the two types of problems. So don't freak out yet. All right, an example. Okay, well, above I said calcium chloride is going to be my starting point. That is my given. And I am going to go to calcium nitrate, which is going to be my unknown. So in this case, let's see if we could write this mole ratio, and we're going to look at the coefficients. All right, so starting off, we have to look at the coefficient for the unknown. Well, what do you know? There's no coefficient there, which means that is 1 mole. All right, because nothing there means 1. CaNO3 parentheses 2. All right, and then I look at my given. Oh, what do you know? There's no coefficient right there. So it is 1. And this is a 1-to-1 ratio. All right, this is our mole ratio. Now, this is going to help us figure out how we can multiply and get moles and grams of another substance. All right, so we're going to start off and just realize that we could find out a lot of different things using these equations. It's like our recipe. All right, if I had 2 eggs, 2 cups of sugar, 1 cup of flour, and I put it all together, how much of a chocolate cake could I make? All right, it's a recipe, a chemical equation is. We could go from moles of one to moles of another, moles of one thing to grams of another, grams of one thing to grams of another, grams to moles, molecules even. All right, we could do so much with this equation. And we're going to use something called a mole road. So if we look at it, we have this like 2 cliffs, and in between it is our mole ratio. It allows us to go from moles of A, whether it's a compound or an element, to moles of B, which is some compound or element. this mole ratio is what gets us there. So every problem that we learn with stoichiometry is going to involve this mole ratio. All right, the coefficients from the equation, and we're going to look at these type of calculations in detail. So let's go ahead with the most basic one. Okay. The most basic one, type 1, is moles to moles. This is the easiest one. It's the number of moles given in the problem times the moles of B in the equation, that's the coefficient of the unknown, divided by the moles A, the coefficient of given, and it gives us the moles of our unknown as an answer. So this is pretty straightforward, all right? This one should be the easiest one, and this will be kind of like our building block to go on to the more difficult ones. So let's just go ahead and look at a problem. Okay, so let's start off looking at our problem. It says, how many moles of Al, aluminum, exist in 13 moles of aluminum oxide? All right, this is my given. All right, this is my given because obviously it gives us a number. All right, and then what I'm asking for, how many moles of Al, this is my unknown. Okay, so we're going to keep that in mind. So the very first thing that it says to write down is number of moles given in the problem. Okay, so I got 13 moles of Al2O3. And now I'm going to multiply it by my mole ratio. All right, my little mole ratio, which involves the coefficients in the equation. So the top one, like we said, is the unknown, and it is the coefficient in front of the unknown. So our unknown is Al. This is the coefficient right there in front of the Al. So I'm going to say 4 moles of Al. All right, and my bottom one is the moles A, which is the coefficient of the given. My given is the aluminum oxide, and I'm going to look at the coefficient in front of it, and here is that coefficient. It is 2, so I say 2 moles of Al2O3. Okay, and now we could solve for this. And a lot of kids have problems solving for this, and you type it into a calculator. It's always times by the top, so that would be multiplication, and then divide by the bottom number. So we're going to take 13 times 4, divide it by 2, and we get 26. All right, now you're probably wondering, okay, well, what's my unit right here? Okay, what's the unit? Well, let's take a look at our problem right here. All right, just in case you haven't figured out, look, I have moles Al2O3, and this is kind of like over 1. That's how fractions work. That's over a whole number. So I got moles Al2O3 right there on the top, and I got it on the bottom over here. So these are going to cancel out. And my unit that's left over says moles Al, which is what I want in my word problem at the top. So that's moles Al. Okay, so moles to moles is just multiplying by this coefficient ratio. The unknown on the top, the known on the bottom. All right, so let's look at type 2, moles to grams. Now this one is simply type 1, but with a little extra part, times the molar mass. All right, that's going to be our key, and this is the molar mass of the unknown. All right, this is going to give us the number of grams. So we were fine with just moles to moles, but what if we need to go to grams? All right, moles to grams is our next step. Okay, so let's go ahead and work out one problem that we have here. We got moles to grams, type 2. All right, I'm going to use this equation, aluminum oxide, and the arrow means yields, aluminum, and oxygen gas. So let's first look through our problem and see if we can find our unknown and our given. Remember, our given is the thing with the number. So moles of Al2O3, this is our given. Okay, now we're going to look for what it's asking for. It says grams of AL, and this is my unknown. All right, so let's go ahead and set up our problem. If we go back and look at our original sheet, all right, it's going to have us first write down our given amount of moles in the problem. So we have 26 moles of Al2O3, and I'm going to multiply it by the same coefficient ratio that I did in the original problem. So the top coefficient is my unknown. All right, my top coefficient of Al, so I'll see that. I'm going to write down 4 moles of Al, okay, because that's the coefficient in front of my unknown. And then the bottom one is my coefficient of my given. Okay, well, my given was Al2O3. So I'll look at the coefficient in front of it. It is 2, so I'm going to say 2 moles of Al2O3. All right, and the next step is to multiply it by my molar mass over 1 mole. All right, this is going to give me the grams for this one. So we know that it's going to be 1 mole of Al on the bottom. All right, now we got to figure out the molar mass for the top. The molar mass of the one I'm looking for is Al. And because that is a single element, I just look at the periodic table of what it is. All right, it's 1 aluminum, which is going to give me a mass of 2698 grams per mole. Okay, so we're going to solve for this, but let's go ahead and check to see if our units are going to cancel. Because I have moles Al2O3 right there, and moles Al2O3 right there. One's on top, one's on the bottom, so they cancel. I got moles Al right there, moles Al on the bottom right there. And please note, the only unit I have left over is grams. There it is right there. So I'm looking for grams AL, and I'm going to end up with grams according to my problem. So we are good to go now. All right, if you type this into a calculator, you're going to type it in as follows, and don't try to split it up. You're just going to say 26 times 4, the top, divided by 2, the bottom, times 26.98, divided by 1 equals 1402.96 if you're going to not round it. Okay, so this is my grams of AL. That's a lot of grams, wouldn't you say? Well, what do you know? This is just a little bit harder than the type 1 from moles to moles. All you're doing is adding on the molar mass of the unknown, all right, to go from moles of one thing to grams of another. All right, if you have any questions, make sure you ask questions in the comments below or your teacher. All right, and then the next one, we will go on to the very next type of problem.